In this video, we'll look at improvements to our DiveView class now that we know more about the Python list class. Using a class for a DiveView is clearly a good design decision to encapsulate the data and methods needed to draw it. In an earlier video, we discussed that naming variables with number suffixes, such as pip1, pip2, pip3, and so on, should usually be replaced with a list. We'll refactor the internal implementation of the DiveView class to use a list as one of the instance variables without changing what each of the methods does. By changing the internal implementation but not the API for the DiveView class, our roller program that displayed two DiveView objects will not need to change. As a quick refresher, here is the original program that created the 7 pips as 7 different instance variables. The data for each of these instance variables is the circle object, as the makePipHelper method returns a circle. To turn off each pip, we needed to write 7 statements to call the setFill method of the circle object. Here is our new version that creates an empty list and then calls the makePip method and appends the result onto the list. When these statements complete, the self.pips instance variable is a list of 7 circle objects. We now need to update the setValue method to use the list instead of the distinct instance variables. The major benefit we get is we can draw each pip in the background color to turn it off using a loop with one statement in the body. 7 calls to the setFill method are still made, so the code is not doing any less work, but it is less work for us to write it this way. Remember that self.pip is a list of circle objects, so when we iterate over it, the pip loop index variable is assigned each circle object before executing the body of the loop. During the first iteration, self.pips bracket 0 and the local variable pip both hold a reference to the same circle object, so we are turning off that circle. During the next iteration, self.pips bracket 1 and the local variable pip both hold a reference to the same circle object, so we are turning off that one. When the loop completes, all the pips will be turned off. Note that even if we made a DiveView for a die with a different number of sides, this loop would not need to change, as the first thing we need to do is turn off all the pips. Next, we need to turn on each pip. Note that since the list indices start at 0, the center circle that was pip4 in the original version is self.pips bracket 3. This is true for each one, so I needed to use the brackets and subtract 1 from each number when making the change. We'll now make a second round of refactoring improvements. Instead of calling the append method, we'll just initialize the list directly by storing the result of each makePip call. This is slightly more efficient than calling append 7 times. The big improvement we will make in this version is to create a table indicating which pips should be turned on for each die value. I've made a list of list objects where each list indicates the pips that should be turned on for that die value. Since the indices start at 0, it is off by 1, so self.onTable bracket 1 indicates the pips to be turned on for the die value 2. Note that self.onTable is a list of lists, and self.onTable bracket 1 is a list of integers. We'll now look at the setValue method and note that it is much shorter. We no longer need an if statement for each die value. Instead, we set the local variable indices to store the indices of the pips that should be turned on for the specified die value. Again, because the first list index is 0, we are off by 1, so we subtract 1 from value to get the list of indices for that die value. So when setting the value to 2, we first turn off all the pips as we did before. Next, we get the list of indices 0 and 6 from self.onTable bracket 1. Now we iterate over that list. The first time through, I will be 0, and we turn on that pip. The next time through, I will be 6, and we turn on that pip. We could have placed the code to create self.onTable in the setValue method, since that is the only place it is used. But then we would need to create a list every time we called the setValue method. This would have a small performance penalty. If we did place the code to create the table in the setValue method, it would not need to be an instance variable. The downside to making it an instance variable is that every DiveView object we create will have a copy of the exact same table. Python supports a concept known as class variables. With the class variable, there is one shared copy of the data that all the objects of that type share. This would be appropriate for the onTable since it is exactly the same for every DiveView, but the pips need to be instance variables as each DiveView has its own circles it needs to draw. In this final version, we make a class variable by assigning the variable inside the class definition, but not inside any of the methods. We do not use self, as self is a parameter to a method, so there is no value of self defined before this. We remove the self.onTable instance variable from the constructor, and now the code would work. We can use self to access the class variable, but I changed it to DiveView.onTable to make it clear we are using a class variable. By making these changes, our DiveView class is now 80 lines of code, and many of those lines are documentation. The original version was 105 lines of code, so we removed 25 lines of code and made the code more organized and easier to maintain. We can run the roller program that uses the new DiveView class and see that it still works the same. While the original version works the same as this one, this updated version of the DiveView class is a better design. When writing code, your first goal should be to get it to work correctly. Once you have it working, your second goal should be to improve the code so it is clear and easier to maintain. A good portion of upper-level computer science courses are looking at better algorithms and data structures to make code more efficient and more maintainable.